Hi everyone. Thanks for having me here to share my research. A lot of the technologies that you're learning about in this class are really changing the way that we live, but they're also changing the way that we can do social science. It's making it the most exciting time ever to be a social scientist, because we can collect and analyze data about human behavior in a way that was never before possible. So in this talk, I'll try to give you one example of that. And it was actually the work that I did in my dissertation, and it was motivated by things like this. So this is Harry Potter. It's the first book from the Harry Potter series. You all have actually probably read it. So as you know, Harry Potter went on to become tremendously successful. It sold many millions of copies around the world. It was translated into many, many languages. And all of that would make you think that Harry Potter is somehow special or better than all the other books. But yet, that was not at all clear ahead of time. So Harry Potter was rejected by 8 different publishers before it was finally picked up. And so that seems like a strange combination, that something that went on to become so successful was so hard to distinguish ahead of time, even for people whose only job it is to find the things that will go on to sell lots of copies. So these publishing people, they're not there to necessarily judge literature, they're there to sell books. And so something that went on to become such a huge success, so many people missed it, seems like a very strange combination. But actually, I could have told you stories about this, stories like this about Star Wars. So as we know, that was obviously a huge success. It was initially rejected by 2 major studios. American Idol, which has been one of the most popular TV shows of the last decade, which one executive called Ratings Crack, was initially rejected by all the major networks, including Fox, before it was eventually picked up by Fox. So more generally than these specific examples, there's a general pattern in the market for cultural products. These are books, movies, music, art, and TV shows, where on the one hand we see extreme inequality of success. So these are sometimes called superstar markets or winner-take-all markets. And this extreme inequality seems to suggest that these winners are somehow different or better than all the other things. But yet at the same time, we see tremendous unpredictability of success. So this is very nicely summarized by the screenwriter William Goldman, who said, nobody knows anything. Now, many of you, the first part of this story may match your intuition. That is, we all see the superstars, and so we have a pretty good sense that there are superstars and there are lots of people who are struggling to make it. This second thing about the unpredictability, it's something that we have a much worse intuition about, because we see a very biased sample of cultural products. So how many people here have heard of Britney Spears? Okay, we don't need to do a fancy poll to answer that one. How many people here have heard of Carly Hennessy? So Carly Hennessy was going to be the next Britney Spears. She was a teen phenom. She moved to LA to make it big. Her demo ended up with the president of MCA Records, who heard it and right away signed her. They invested $2.2 million in the production and marketing of her first album, Ultimate High, and it sold 378 albums in the first 3 months. So they pulled the plug, and then we don't see Carly Hennessy ever again. And so for every Britney Spears, there are hundreds of Carly Hennessys, but we never see them. But if you talk to people who work in these industries, they say over and over again, we have no idea what's going to happen. So even though you may think you can predict what will be successful, that's largely an artifact of your very, very biased sample of what you see. Okay, so this is the puzzle that we want to explain. So it seems strange that these 2 things would co-occur. That is, if there are these superstars, it seems like there wouldn't be a lot of unpredictability. So this is the puzzle that we want to understand. And then the argument that I want to make here is that social influence, the process whereby people are influenced by what other people are doing, leads to a process of cumulative advantage, which leads to both the inequality of success and the unpredictability of success. So these 2 things that seem to be somewhat contradictory can both arise out of the same individual level process. And so this argument is also very much at the core of what sociologists try to do. That is, we see patterns in society, collective level patterns, and then try to understand how individual behavior can lead to those collective patterns. So why might this be true? So why might people be influenced by the behavior of others? So I think you've probably already talked about that a lot in this class. And a moment of introspection might lead you to suspect that as well. It turns out there are a lot of complicated things that can be bundled into the idea of social influence. Like, we don't know exactly why people are influenced by the behavior of others. There are many possible reasons. But if popular things become more popular, that leads to this feedback process, which you can call cumulative advantage. And then that can lead to the inequality of success, which you can sort of imagine. If things keep growing and growing, big things grow more and more and more, that can lead to big variation. And it can also lead to unpredictability, because one time this snowball could form one way, but if you could rewind history and do it again, the snowball could form a very different way. So that's sort of the intuition behind the argument. Now, the problem is that this argument is very difficult to test. So because I'm sort of saying, basically, let's return to Harry Potter. So I might say Harry Potter is lucky. It's a result of a cumulative advantage process created by social influence. And you might say, no, Harry Potter is just good. And I might say, no, it's really lucky. And you might say, no, 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 I've read it and it's good, and there's something about boy wizards. So basically we could go on and on with this conversation forever, because the one data point that we have is consistent with both of our explanations. So if we want to try to resolve this, we need some new way of collecting data. So imagine now that we had perfect data on every book that was sold in the US. So that data is something approximating that data is now available from a market research company. But even with that, it's very hard to argue that some other outcome could have occurred. So what we'd really like to do is take the world and rewind it to the day that Harry Potter was first released, and then make 8 copies of the world and have them all evolve independently. And if Harry Potter became popular in all of those, then we would say, okay, Harry Potter is really good. If Harry Potter became popular in one but not the others, then we would say that it's lucky. So it's like, to see the role of chance, you need to see multiple outcomes of the same process. If I just roll a die once, you won't know whether that die is really stochastic or whether it's deterministic. So we can't actually copy the world and run them in parallel, but what we can approximate that in an experiment, and that's what we did. So this experiment, just to set the stage a little bit more, is different than many of the experiments that you're used to seeing. So it involved, first of all, by doing it on the web, we're able to have many more participants than a traditional lab experiment in the social sciences. How many of you have been in an experiment run by people in the psych department or the econ department? Yeah. So that kind of model is the way that most social sciences happened in the past. They usually involve hundreds of people in a lab on campus. These experiments involve 27,000 people. So it's bigger than a normal experiment by a factor of 100. And so this is not just a quantitative difference, it's a qualitative difference. It allows us to do new things, different things than people could have done before. But it's a little bit different than many of the experiments you're used to seeing, because in many experiments you've seen, the individual is the unit of analysis. So in a psychology experiment, they want to study how individuals behave. In the sociological experiments, the collective outcome is the unit of analysis, the group. And so if we want to study many groups, we very quickly need lots of people. It's like the difference between studying jury members and studying juries. So if you want to study juries, there are things about juries that are not necessarily easily reducible to the jury members. And if you want to study juries, you very quickly need lots of people, because each jury takes 12 people. In this case, each of these parallel worlds we had took about 700 people. So it's just basically not possible to do on campus, because we would never get enough people. Okay, so what did the website look like? So people came to this website, musiclab.columbia.edu, so that it was clear that they were participating in a scientific research project. After Clicking through this, they were taken to a consent form, then they filled out a brief survey, taken to a page of instructions, and then they saw this. So this is 48 songs by up-and-coming but unknown bands. They could click on one that looked interesting to them. The song began playing, and they were asked to rate it on a scale of 1 to 5 stars, and then they were offered the chance to download the song. After that, they were taken back to the song menu, and they could listen as many times as they want. So that's the experience that an individual user had. Now, behind the scenes, they did not know this. This was the design of the experiment. So when people were coming to the site, we randomly slotted them into 2 different conditions. So in one condition, people had no information about what other people were doing. This is like we call the independent condition. This acts like a control condition. And we also have what we call the social influence condition, where people could see what other people were doing. But further, we divided that social influence condition into 8 parallel worlds. So people could see what other people in their world had done, but not what people in the other worlds had done. So this gives us these 8 parallel histories that we're talking about. And then this gives us a control condition to compare the outcomes that we would have seen in the absence of social influence. So we did, I'm going to talk first about 2 experiments that we did. So first is this version of the experiment which you saw. This was the first experiment where we had a weak amount of social influence. So you can see the popularity of the songs are available, but they're not sorted by popularity. So the information is available, but it's not particularly salient. And then we said, well, let's see what happens if we turn up the amount of social influence. What are the consequences of that change for the collective dynamics that result? So in the second experiment, we sorted the songs by popularity in a single column. Now it's much more salient what the most popular thing is. So then the question is, how does this individual level change in the behavior that people, the behavior that we try to induce, affect the collective level dynamics of the inequality and unpredictability of success? So here's what we found. So this is a graph showing the inequality of success in experiments 1 and 2, measured in terms of the Gini coefficient, which is a standard measure of inequality. So here are the 8 social influence worlds, and here's the independent world from experiment 1, and we see that the results in the social influence world are more unequal than they are in the independent world, which is what we had predicted, and that when we increase the amount of social influence, the amount of inequality goes way up. The stars become megastars and the flops become mega flops. So many of you are probably not familiar with the Gini coefficient and what's the difference between a Gini coefficient of 0.34 and 0.5. So to put that in some context of current levels of income inequality, so this is equivalent to the income inequality in France, and this is equivalent to the income inequality in Nigeria. So that even though that is a big difference that we're able to see by increasing the amount of social influence. So then what's the effect of increasing the amount of social influence on the unpredictability of success? We see that the unpredictability of success doubles. So how do we define unpredictability here? Let me be a little more clear about that. So we have these 8 success outcomes from these 8 parallel worlds. So imagine that each song had the exact same success outcome each time. Then we would say that song is not unpredictable. It might be hard to predict, but it's at least possible because it gets the same thing each time. To the extent there's variation across these 8 outcomes, there is some inherent unpredictability in the results, in the same way that there's inherent unpredictability in the roll of the dice. So this unpredictability measure is a measure of the variability across these 8 parallel worlds, and as the amount of social influence increases, the amount of unpredictability also increases. So to make this a little more concrete, we had one song, Lockdown, by the band 52 Metro. So in one world in experiment 2 it came in first, in another world it came in 40th out of 48. It was exactly the same song, competing against exactly the same other songs with indistinguishable starting values, with indistinguishable groups of people because we have random assignment. So to wrap up this, together these experiments show a sort of dose-response relationship whereby increasing the strength of the social influence leads to increased inequality of success. In other words, it suggests the increased importance of skill. So that is, as the inequality increases, as the stars become superstars, there's a greater sense that you might suspect that skill has become more important. But yet, if we could look across these parallel worlds, we would see that actually luck has become more important. So let me try to express this in a different way. So if I came here and I said to you that the New York Times bestseller list affects which books people buy, that probably wouldn't be very surprising to you. I wouldn't need to do a lot of work to convince you of that. Now imagine if I came here and I said the New York Times bestseller list increases the inequality in success in publishing. You would probably agree with that, but you would probably like to see some more evidence. Now if I came here and I said the New York Times bestseller list actually increases the unpredictability of success in publishing, that seems much more counterintuitive, but that's very compatible with what we found here. That is, in some people's minds, there's this intuition that if we have more information about what other people were doing, somehow we'll all collectively find the best things faster. But that's not always the case. So if you have people who are following people who are following people who are following people, those kind of fads can become completely disconnected from any underlying reality. So if you all have studied information cascades in your class, this is a very similar idea. Right? Having information about the behavior of others can actually lead to worse aggregation of information, not always better. So we can also use this design to look at the relationship between quality of songs and their subsequent success. So by looking at the download behavior of people in the independent condition, we can measure the quality of the songs in the absence of any social pressure on participants. So here in the x-axis we plot the market share in the independent condition. So this is roughly a measure of quality. And then in the y-axis we plot the market share in the 8 social influence conditions. So you can see the range of results here. So when I said the results are unpredictable, that does not mean that the results are random. So you see here there's a strong relationship between quality and success, but there's some noise. And then as we move from experiment 1 to experiment 2, you see the amount of noise increases dramatically. So the range of possible outcomes gets much bigger. You can also see a sort of cone-shaped structure here. And so I actually, I was showing this plot to the head of research at NBC while I was doing this project. And I was very excited to have this plot, and I showed it to him, and he said, "Oh, I already knew that." I said, "Wow, like what did you already know?" And he said, "Well, I can predict failure, but I can't predict success." And so I think that is a great way of summarizing this plot. So for these bad songs, they pretty much always do poorly. But as you move up in the quality range, the range of possible outcomes gets much bigger. So it's much easier to predict failure than it is to predict success. Okay, so those results, we basically let these worlds evolve naturally. We didn't interfere with them in any way. However, that's not a completely... However, in actual cultural markets, that doesn't always happen. In fact, people sometimes systematically intervene in them. So this, for example, is a book called The Bureau and the Mole. It's about a KGB spy in the CIA, and it's written by David Weiss, who is a Pulitzer Prize-winning journalist. When this book first appeared, someone bought and then returned 17,000 copies of this book. And a little bit of investigation revealed that it was actually David Weiss, the author of the book. And so he argues that this was totally innocent and had to do with some kind of thing. He was going to sell the books himself or something. I don't know. So he argues that this was innocent. Many people accused him of trying to create a self-fulfilling prophecy. That is, to push the book onto the bestseller list so that then people would actually buy it, and that initially false perception of the situation would become true. So this is what sociologists call self-fulfilling prophecies. It was a term first introduced by Robert Merton in 1948. And again, it's an initially false perception of the situation that changes people's behavior in such a way that the initially false perception becomes true. So a classic example of this is a bank run. So imagine that we all think that our bank is in danger. We'll go and withdraw our money, and then the bank will actually fail. So sociologists are very interested in processes like this because they suggest that lots of things that appear to have some sound basis in the world are actually largely just things that we all sort of agree on. They're all social constructions. So for example, you might think that the solvency of your bank is something that is grounded in deep fundamentals and the expected values of the loans in their portfolio and so on. But to a large degree, the solvency of your bank is also in everyone's head. That is, if we all collectively thought that your bank might fail, then your bank actually is at high risk of failing. So we wanted to see to what extent we could create things like these self-fulfilling prophecies in our experiments. So the design we used is as follows. So we allowed the popularity of the songs in one of the social influence worlds to run for a while until it had reached something like an equilibrium. Then we took this world and we made 3 copies. And in one world, we left that unchanged. In the other 2 worlds, we inverted the popularity. So we told people the least popular song was the most popular, the second least was the second most, and so on. And then the question is, if you have this system that's basically at equilibrium and you give it a big shock, what's going to happen? Is it going to return to its original configuration? Is it going to move to a new configuration? So on. Also, one other question that you might have is, why did we do 2 of these inverted worlds? So we found in the previous experiments that even worlds with the same initial conditions can have very different dynamics. And so we wanted to have multiple inverted worlds to see whether they behave the same or not. Okay, so that's the experimental design. Now let's look at what happened. So here's during the setup period. So this is the number of downloads over time for song 1 and song 48. Then in the unchanged world, we see pretty much no change, so that's good. What do we see in the inverted worlds? So we see when song 48 was placed up into song 1 spot, it got many more downloads than it did when it stayed at the bottom. Right? You can see this difference between here and here is much bigger than the difference between here and here. So it had an effect on the popularity of the song. But if you project this out, it looks like song 1 will eventually overtake song 48. So it looks like this had some effect on popularity, but it doesn't look like this will become self-sustaining. Let's now look at song 2 and song 47. And here we see a very different story. So it looks to be the case that if we project this out, once song 47 was placed in song 2's spot, it got more listens and more downloads. And so this initial change was able to lock in and become self-sustaining. Now, if we look at the entire market as a whole, we get something that looks like this. So here what we've plotted is the rank correlation to the final outcome at the end of the setup period. So here we see that very quickly the system moves into something that's very closely correlated to its final configuration. And then in the unchanged world, it basically stays about where it was, which is what we would expect. Here, the inversion, we go to a -1 rank correlation. And then we see that the world gradually starts to recover, but it seems to get stuck at some intermediate state. So imagine, again, you invert the world. If you believe that quality is a dominant thing, you would expect that it will gradually right itself. We definitely do not see that. If you believe that it's entirely a process of social influence, you would expect that once it's inverted, it will basically stay inverted. That's not what we see either. We see something in between. That is, it starts to unwind, and then it gets stuck at some intermediate state. So now you may wonder whether this could really happen in the real world. That is, we've been able to do this in an experiment, but these experiments are clearly not like the real world in many, many ways. So this is something that social scientists call generalizability or external validity. That is what we can learn applicable in lots of situations outside of the situation we've been studying? So it's a very, very hard question to answer, but I'll try to give you one historical case study which maybe suggests that this could happen elsewhere. And in fact, I would argue it's already happened with one of the most famous works of art in the world. So we all know the Mona Lisa. We all know the Mona Lisa is tremendously famous. What many people do not know is that this was not always the case. So up until about 1900, the Mona Lisa was not a particularly famous painting. But that needs to be, there's a couple caveats that need to be understood here. So this was in the Louvre, painted by a famous old master. So it's not the case that it was unknown, right? It was a painting in the Louvre, right? So that's pretty good. I'd be happy if any of my paintings ever ended up there. What I mean is, relative to other paintings in the Louvre, it was not particularly well known. And we know that from two sources. All of this, by the way, is excellently and very thoroughly detailed in a book by Donald Sassoon called Becoming Mona Lisa. So the first piece of evidence that we have is insurance records. So the Louvre had to value all of their paintings in case there was a fire. And so in these insurance records, we see that the Mona Lisa was not the most valuable painting in their minds. Second, there are paintings that artists have made of visitors in the museum. So if you're going to paint people visiting the museum, you paint them looking at the most famous paintings, and they were not looking at the Mona Lisa. But then something happened. So in 1911, the Mona Lisa was stolen. Someone walked into the museum, took the painting out of the frame, rolled it up, put it in his jacket, and walked out. So this created a huge burst of publicity for the painting. Then, a few years later, when it was recovered, it was turned out that the thief was an Italian, and he claimed that he was stealing it to return it to Italy, where it was originally painted, and he claimed that it was actually looted by Napoleon, and so that it rightfully belongs in Italy and not in France, that's actually not true historically, but that was his justification for his theft. So this created another big burst of publicity because some Italians said, no, we should keep this painting, it's part of our heritage, and so on. So this event of stealing the painting led to these two large bursts of publicity for the painting. And then when Duchamp was looking for something to parody, he picked the Mona Lisa. So why did he pick the Mona Lisa to parody? He picked the Mona Lisa because it was already famous. And then what were the consequences of that? It made the painting even more famous. And that leads to and finally more recently. So all of that leads to this. So if you go to the Louvre today, you will see something like this. And if you were an alien from Mars and you came down and saw this, your first intuition would be that there must be something very special about this. But actually what we can see in this history and what we can see in the experiments is perhaps it actually has much more to do with this. So thank you all very much. You can read our papers. This also gives me a chance to acknowledge my collaborators on this, Peter Dodds and Duncan Watts. Also, all the data from all the experiments is publicly available. You can download it and analyze it however you'd like. And also in the spring I'll be teaching a course about social networks that will cover some of the same things as are covered in this class, also some different things, but we'll cover everything from a much more sociological perspective.